I hope everyone's having a great day. I'm Mr. H. Thank you for joining me. We're looking here at a very good but useful video, a short video, a trigonometric trap related video. There are questions out there with regards to these trigonometric expressions or equations where you have to find the values of x or theta. These thetas could very well have been x's, sine 2x is equal to sine x, where you have to find all the acceptable solutions of that equation. The trap is this, that once you simplify your initial expression and you're ready to find your values, you might take a shortcut route, which normally in algebra you would, but in these type of questions you wouldn't, because you'll end up missing a few of the viable solutions that would be present. Look what I do over here. Sine 2 theta is a trigonometric identity which is really equal to 2 sine theta cosine theta. Remember that identity sine 2x is equal to 2 sine x cosine x. Well, that's exactly what we're talking about. And then you know it's equal to this on the other side. The shortcut which some students might make in terms of algebra is they would cancel this out with this, because it looks like it's the same thing, and here you could take this and divide it and you would have 2 cosine theta is now equal to 1. And then they'd solve for this theta, cosine theta is equal to 1 over 2, and then they'd say theta is equal to the inverse cosine of 1 over 2. The angles of cosine, which would give you a value of 1 over 2 in terms of everything between 0 and 2 pi, including both of those, would be 60 degrees and 300 degrees. Your first and your fourth quadrant angles for cosine are always positive, and you would say here it's pi over 3, which is 60 degrees, and you'd say 5 pi over 3, which is 300 degrees. And it would seemingly look right, but it wouldn't be good enough because you've missed out some solutions. You missed them out because you did this cancellation when you should not have done that. A better approach would be this. We will erase everything. We'll come back to exactly where we started right over here. You'd open this up, sine 2 theta as 2 sine theta cosine theta is equal to sine theta, and you'd make this into an expression equaling 0. You take this on the other side, and look what I do. 2 sine theta cosine theta minus sine theta is now equal to 0. Rather than you cancelling it out, you can isolate sine theta and you have 2 cosine theta minus 1, which is exactly what you had in the previous way of doing it, but now you've gotten this. You have two separate equations. Sine theta is equal to 0 and 2 cosine theta is equal to 1. Cosine theta here is equal to 1 over 2, and you know here from this part theta is equal to pi over 3 and 5 pi over 3. 60 degrees and 300 degrees, but from here we know now theta is equal to 0 degrees, it's equal to pi, and it's equal to 2 pi, because sine of 0, sine of 180, sine of 360 is equal to 0. Here you're getting 3 more solutions which you weren't. Otherwise you were relying on getting only 2 solutions. Now you have 5. 0 pi, 2 pi, pi over 3 and 5 pi over 3, and this right here is a good way. The trap is, do not simplify in that way in terms of a algebraic form of simplification, because you'll end up missing out solutions. Try to take everything on one side and make it equal to 0, and then proceed from there, and you'll end up with more of the proper solutions. And that's it. Thank you for watching. Have a nice day.